This is Algebra 2, Lesson 1.2. We're going to continue talking about sequences, but we have a new type of sequence, a geometric sequence. So a sequence is still a list of numbers, but geometric sequences are generated through multiplication. Now that's technically also division, but we're going to focus just on multiplication. So an example would be 2, 4, 8, 16, 32, etc. Or how about 10, 100, 1,000, 10,000, etc. We could even do like 100, 50, 25, 12.5, etc. Okay. The common ratio is the number that you multiply. And our formula for that, to get the ratio, we take the second number and we divide it by the first number. Our recursive formula is going to look just like it did with the arithmetic sequences, but multiplying by the ratio as opposed to adding the difference. If we forget what this means, remember this is to get the next answer. You take the last one and you multiply it by whatever your ratio is. We have two other ways to find the ratio if you're given a percent increase or a percent decrease situation. A percent increase, you do 1 plus whatever the percentage is, and a percent decrease, you would do 1 minus whatever the percent is. Now both of these, keep in mind that percents versus percents as decimals require a little bit of extra calculation. So to show you an example, a 12% increase, you would do 1 plus 12%. And remember, 12% is the same as 0.12 because you move that decimal 2 places. So my percent increase would be 1.12. And think about it, if you have 100% and then you're increasing 12%, you have 112%. And that as a decimal is 1.12. I'll do an example of the decrease. Let's say you have an 8% decrease. Your ratio would be 1 minus 0.08, because 0.08 is the same as 8%, and so that's the same as 0.92. And so putting that in other terms, if you have 100% and you decrease 8%, you're left with 92%, and that as a decimal is 0.92. First example shows a geometric pattern. This is called the Sierpinski triangle. So I'm going to find the number of shaded triangles in each figure. So my first figure has 3 shaded triangles, my second has 9, and my third has 27. To find the ratio between terms, I'll take the second answer and divide it by the first answer. So I show that I'm increasing by multiplying by 3 every single time. So my formula then gives me my first term and how I change. My first term is 3, and I'm changing by multiplying by 3. Letter B says, how many shaded triangles will there be in the 20th figure? So I have my calculator here, and I'm going to key in my starting value and then hit enter. And then I'm going to multiply that by my ratio, and every time I hit enter, I get the next term. So my first term was 3, my second is 9, my third is 27, and I got to keep going all the way to number 20. So that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. At my 20th term, I'm well over 3 billion shaded triangles. So let's see if I can get this number recorded. 3, 4, 8, 6, 7. 3, 4, 8, 6, 7. 84401. And specifically, that is 348. Is that right? Oops. 348 I missed a number. 34867. Maybe I didn't. Oh, I see what I did. I had my comma in the wrong spot. Okay, right there. Right there. 3,486,784,401 shaded triangles. Okay, example B. An automobile depreciates as it gets older. Suppose that a particular automobile loses 20% of its value each year. Write a recursive formula to find the value of the car when it's 6 years old if it cost $23,999 when it was new. So I'm going to do my calculation to get my ratio. This is a percent decrease situation because I'm losing 20% of its value. So if I have 100% of the value and I take away 20% of the value, I retain 80% of the value. That's 0.8 as a decimal. My formula needs two pieces of information, my starting term and my how I change. And so this is a little different than when we were doing the arithmetic sequences. I'm putting a U0 down instead of a U1 down because the 23,999 is the value of the car when it's 0 years old as opposed to the value when it's 1 year old. And this way I can keep track of my years a lot easier. I've already calculated the ratio, so I know I can put the 0.8 on my formula, and now this is my formula, my starting term and how I change. I'm going to key this into my calculator to answer the question, what's the value when it's 6 years old? So I need to figure out U sub 6. On my calculator, I'm going to put in my 23,999 for my starting value. I'm going to multiply that by my 80% that I'm retaining from the value. And after 1 year, I have a value. And after 2 years, and 3 years, 4, 5, 6 years, my car is worth $6,291.19. And example C, Gloria deposits $2,000 into a bank account that pays 7% annual interest, compounded annually. That's a little redundant. This means the bank pays her 7% of her account balance as interest at the end of each year. And she leaves the original amount and the interest in the account. When will the original deposit double in value? So I'm going to do a little side calculation to get my ratio. If I have 100% and I'm increasing 7%, that's 1 plus 0.07. I have 107%, which as a decimal is 1.07. So my formula, I need my starting value, and at the start, after 0 years of interest, we have $2,000. To get my next term, I take the one before it, and I multiply by 1.07. The question is, when will we double in value? Since I started with 2,000, the question is, when will I reach $4,000? So I'm going to use my calculator to see that information and count until I see my first value above 4,000. So I'm starting with $2,000, multiply by 1.07, and after 1 year, 2 years, 3 years, 4, 5, 6, 7, 8, 9, 10, 11 years, I see my first value over 4,000. So I will write U11 is 4209.70. So the answer to the question then is 11 years. That is it for the notes. Good luck on the exercises, and please let me know if you have any questions.